Our next topic in this series of simplified chemistry is electrochemistry. Electrochemistry. Objective. Our objective is quantify mass liberated or deposited during electrolysis. Quantify the mass liberated or deposited during electrolysis. So first we go to Faraday's first law. Which talks about the mass liberated. Faraday's first law. So Faraday's first law of electrolysis so states that the mass liberated or deposited at any electrode is directly proportional to the amount of charge passed. So the states that the mass liberated or deposited at an electrode is directly proportional to the amount of charge passed, which is equal to N is equal to coulombs over F. F is the Faraday's constant, which is equivalent to 96,500 coulombs per mole. So that is the charge of 1 mole of electron. That's the charge of 1 mole of electron, coulombs per mole. So when quantifying the mass deposited, you have to follow the following steps. One, you have to use the first question. You have to follow steps to follow. So steps to follow. So step one, quantify coulombs from electricity, which is coulombs times time in seconds. Then you calculate number of moles of electron from coulombs, which is Faraday's constant. Then you convert the mole ratio. You get the mole ratio. Then step four, convert the mass of atom from the moles, which is multiplied by V star. So these are 4 steps. IT, moles of electron convert from coulombs. Then compare the mole ratio of electrons to mass of substance liberated or deposited. Then you change the moles of a substance liberated to mass. So this is how you follow. Example. Which is example, which is example 1. Example 1, which is 1. What mass of copper? What mass of copper is produced at the cathode when 2.4 a current is passed through the solution of copper 2 sulfate at 25 for 25 minutes. That is the question. So for this, we have to follow our 4 steps. Step 1, C is equal to CIT. 2, step 2, we convert number of moles of electrons, which is C over Faraday's constant. Then step 3, mole ratio. Then step 4, mass. We get the mass from number of moles. So for this question, what's the mass? So we start C is equal to IT. So current is 2.40 multiplied by time, which is 25, multiplied by one. How many minutes? How many seconds make a minute? That is 60 seconds. So 60 multiplied by 60 seconds, which is equal to which will be equal to 2.40 multiplied by 25 multiplied by 60 is equal to 36,000 coulombs. 36,600 coulombs, which is F. Then from there we go to number of moles. We convert the charge to number of moles of electrons. So over F. That is step 1. Number of moles go to number of electrons over F. That is 36,600 coulombs divided by Faraday's constant, 96,500 coulombs per mole. So coulombs per mole, coulombs and coulombs goes. So we have 3600 divided by 96,500. That is 0.0373 moles of electrons. Then we go to the third step is mole ratio. So mole ratio, we go to what was the charge of this? It was copper 2. So copper 2, how many moles would reduce, how many electrons will reduce copper to copper metal? So 2 electrons. So 2 electrons will be reduced by 2 electrons since the charge is 2. So it will form copper like that. Then how many moles here? So 1 mole of copper should be equal to 2 moles of electrons. 2 moles of electrons. What of these moles of electrons, which is 0.0373 moles of electrons, will be equal to how many moles of copper? x. So cross multiply, this is 2x is equal to 0.0373 over 2. So x is equal to 0.0373 divided by 2. So it's equal to 0.01865 moles of copper. So since we have the moles of copper there, the moles of copper, which is the 0.01865 moles of copper. So what mass? So we go to the mass of copper, which is the mass of copper is equal to Mr multiplied by number of moles, which is equal to Mr is 64 grams per mole multiplied by the moles, which is 0.1865 moles. So mass of copper is equal to 0.1865 multiplied by 64 is equal to 1.1936 grams of copper. So how many? So mass of copper, we have 1.19 grams of copper produced. 1.19 grams of copper produced from 2.40 of current of charge, which is current. So another example. So from 2.40 of current, in 25 minutes we followed CIT. C is equal to CIT, which is here. C is equal to CIT. It's got 2.4 times that we got the coulombs. And the coulombs, we change the coulombs to number of moles. So number of moles in this given charge, number of moles of electrons, we get these moles of electrons. Then we compare the mole ratios, that is 2 to 1. Electrons, copper is 1, this is 2 to 1. Then we get that. Then the moles of copper, we multiply by mixed of copper, which we get that. So we got to example 2. Example 2. Example 2, which is example 2. In example 2, which is question 2, in 45 minutes. In 45 minutes, 30 grams of iron is obtained from is obtained by the electrolysis by the electrolysis of iron 2 nitrate, iron 2 nitrate, which is the iron 2 nitrate solution, iron 2 nitrate solution. Calculate the current required. Calculate the current. Calculate the current required. Calculate the current required. So since we are calculating current required, we go to our usual method, which is equal to C is equal to CIT. CIT is equal to, then we follow number of electrons, moles of electrons over F, Faraday's constant. Then our 3, that is the mole ratio. Then our 4, that is the mass. It's equal to Mr. Our 4 is equal to mass is equal to Mr. multiplied by number of moles. So we follow the following steps. But this is for collecting the mass. This is where you are when you are going to get the mass. But the question has been up. The question now is coming, like we are getting they're asking for current, which is so this one, which is the first thing which we are supposed to in the formula. So for this, when you are starting calculating current, you have to start with this formula from this end. So from this end, so that's where you start from. So you start with this formula. So start with this one first. So from this formula, then you follow this formula, mass of iron, then molecular mass, mole ratio, then you got to change the charge, then like that. So we start with from that end because we're calculating the current. If you are calculating the mass, you have to start from here. But since we're calculating the current, we start with from the far end. Then so number of moles is equal to mass over this formula, which will just interchange the formula. This formula, which will be mass over Mr. So mass of iron, which is 30, over Mr. of iron, which is 56 grams per mole. So 56 grams per mole, which is going to be 30 divided by 56. That is the 0.5336 moles of iron, which we collect moles of iron. Then we go to mole ratio. This is iron 2. So it means iron 2, it means the charge will be 2. It will need how many electrons to be discharged? It will need 2 electrons to be discharged. So, it will need 2 electrons to be discharged, it will need this to be discharged. So, mole ratio is equal to 1 mole iron is equal to 2 moles electrons. So, then how many moles of iron there? That is 0.536 moles iron will produce how many moles of electrons? X. So X. So here X is equal to this one cross multiply. So 2 times 0.5336 moles. So this one we get 2 times 0.53 536. We get 1.072 moles of electrons. So moles of electrons. So since we have those moles of electrons, we can now change the moles of electrons. We can now interchange this formula. We get the coulombs. So the coulombs is equal to, we interchange number of moles multiplied by F, which is equal to number of moles of electrons equal to 1.072 moles multiplied by Faraday's constant, which is 96,500 coulombs per mole. So more than moles goes, we remain with the coulombs. The coulombs will be 1.072 times 96,500, which is equal to 13,448 coulombs. So since we get that coulombs, then we can get the current. So current, we interchange the formula. Current will be equal to, we make I the subject to the formula, so which is the current will be divided by time. So current will be equal to C over time. So C, which is 103,448 divided by time, which is the 45 minutes. 45, you change it to seconds, which is times 60 seconds. So this one is equal to 103,448 divided by 45. 45 multiplied by 60, 38. So this one is equal to 38.3 A current. So current, which is I, is equal to 38 A, which is the current required to reduce this amount of copper, which is 30 grams of copper, to deposit that amount of copper. So this has been electrochemistry and quantify mass, liberated or deposited, given 2 examples. So we'll solve more examples. So make sure you check more videos where we'll solve more examples on this question. So see you online, and we'll see you. So keep subscribing. Thank you so much. Bye.